Okay, this is the homework help video for Math 3, Unit 4, Objective 5. And so for question number 8, what you're looking for are asymptotes and holes. So you're not looking to graph it, just for your asymptotes and holes. So the first thing that you should always do is you want to completely factor and reduce. So for the top here, I want to factor that. So I know that for factors of 2, I would use 1 and 2. And they can either both be positive or both negative. And in this case, they'll both be positive because my middle term is positive. And then I have x plus 4 in the denominator, and then that doesn't factor at all, so that would just give me x plus 4. Okay. So the first thing I want to look for is my vertical asymptotes. So my vertical asymptotes, I always look in the denominator. So whenever I'm looking for my vertical asymptotes, I always want to look in the denominator. And then I look for the zeros. So I would have a vertical asymptote whenever x would make this be 0, so that would be at -4. So I have a vertical asymptote at -4. And then for the holes, I would have none. And the reason I have no holes is because nothing canceled. So like if this was an x plus 4, then that cancels, so I would have a hole at -4. Or if this was an x plus 4 here, that canceled, I would have a hole at -4. So there's no holes because nothing cancels. Okay, and then the next thing I would look for is I either have a slant asymptote or I have a horizontal, like I won't have both. Okay, so I either have a slant or I have a horizontal. So in this particular problem, I would have a slant asymptote because I'm top heavy, right? So I have a higher power on top than the bottom. So because I have a higher power on top, then I would have a slant asymptote, not a horizontal. So if these were both powers of x, I would have a horizontal. Okay? But the slant, this is 1 degree higher on the numerator, so that's why I have a slant. So in order to find a slant asymptote, okay, so the degree on top should be higher. Okay. And then in order to find it, I'm going to do long division or synthetic division. And I'm going to do synthetic division. Okay, so you can do either one. So I'm going to take my original problem here, and nothing canceled, so that's why I can use my original. And then I'm going to set up my division problem. So I'm going to do synthetic division. So I have x plus 4 as my divisor, so the root of that, or the 0 of that, is -4. And then the coefficients go up here. So my coefficients are 1, 3, and 2. So you have -4, and then 1, 3, 2. And then we carry down the 1. And then I multiply by -4. So -4 times 1 is -4. And then I add going down. So then I'm going to do 3 plus -4 is -1. And then multiply by -4. So -4 times -1 is +4. And then add going down. And then once I get here, I always ignore the last term. So I'm ignoring this last term. So I ignore that. And then I use these two numbers here to create an equation of a line. So this started out as an x squared, right? So x squared problem. But then whenever we divide, we reduce by 1 power. So then this equation will turn into y equals, and then 1x minus 1. Okay, so my slant asymptote is, so I just take that, put an x with that, so 1x, and then this is my constant minus 1. And I don't have to have this 1 here, right? So I could just write x minus 1. So there's my vertical, I have no holes, and I have a slant asymptote, not a horizontal asymptote. Okay, so there's question number 8, my asymptotes and the holes. Okay, so let's take a look at another one. Okay, so for question 22, they wanted us to do everything with this one, okay? So the first thing we always want to do is try to factor and reduce. So I can do, let's see, I can do a GCF here. So I can pull an x out of both of those. So I'm going to take an x out. And when I divide an x out, I would get 2x plus 1. And then in the denominator, just x plus 1. And I can't factor that anymore, so that's going to stay the group. Okay, so first thing I want to look for is my asymptotes and wholes. So I'm going to start with my vertical asymptote. So now remember, for your vertical asymptote, you always look in the denominator. So we're looking in the denominator for my vertical asymptote. So I'm going to look here. And so x plus 1, where would that be equal to 0? So that would be at -1. So I have a vertical asymptote at -1. And then there are no wholes because nothing cancels. So I'm graphing this, so I'm not going to write none because it's not specific to find it. So there's no wholes though because nothing cancels. And then I'm either going to have a horizontal or a slant. I'm not going to have both. Okay, so either a horizontal or a slant. I'm not going to have both. So if I look here, so I look to see, so I'm going to go back to my original problem right here. So I don't have matching powers and I'm top heavy. So top heavy meaning I have 1 degree higher on top. So because I have 1 degree higher on top, that means I'm going to have a slant asymptote, not a horizontal. Okay, so 1 degree higher, I have a slant. So to do that, I want to do either long division or synthetic. So I'm going to do synthetic. So I have x plus 1, so that means my root is -1. And then I'm going to do my coefficients. So I have a 2, and then 1, and then I don't have a constant, so I'm going to fill it in with a 0. So 2x squared plus 1x plus 0. Carry down the first number, and then multiply by your divisor's root. So -1 times 2, and then add going down. So 1 plus -2 is -1, and then multiply by -1, and then 0 plus 1 is 1. Okay. And then ignore, right? Throw out your remainder. So then I'm going to take that and turn that into the equation of a line. So I'm going to have y equals, and then 2x minus 1. Okay, so 2x and then minus 1. So there's my vertical and my slant. So now the other part I need are my x and my y intercepts to be able to graph, right? So I need to have the x-intercepts and the y-intercepts. So I know that I have an x-intercept whenever y is equal to 0. So here's my equation, right? So if I want this fraction to be equal to 0, then I want my numerator to be 0. So whenever I do my x-intercepts, it's always when the numerator is equal to 0. Okay. So in order, so I have my two factors here. So I have x and 2x plus 1, and I want that to equal 0, right? Because I don't want my denominator 0, because that makes it undefined. So I just set the numerator equal to 0 and then solve each of these. So when x is equal to 0, so that's one x-intercept. And then I'm going to set that one equal to 0 also. And then just do normal solving. So subtract 1 and divide by 2. So there's another x-intercept. And then finally, one more thing here. I need to find the y-intercept. So in order for me to find the y-intercept, I would let x equal 0. Right? And then I can do that on the original or the factored form. It doesn't really matter which one I use. So I'm just going to do it of the factored form. So I'm going to take the same equation here, and I'm going to turn all of the x's into 0. So that would be 0, and then 2 times 0 is 0 plus 1. And then in the denominator, 0 plus 1. So I would have 0 times 1, which is 0, divided by 1, which is 0. So y equals 0. So there's my y-intercept. Okay. All right, so now we're going to go ahead and graph it. Let me zoom out just a little because I'm going to need a little bit of space here. Oh, I can't. Okay, so let me see if this helps a little bit. There we go. Okay, so I'm going to just do a graph here. And then, that's a terrible graph. Okay. Okay, so let me do a graph over here because you can't see that. That's way too big. Hold on, people. Okay, let me start over. Okay, so let me do a graph. Give myself enough room. Okay, and then I'm going to count out to like, I don't know, 5 or 6 here. And so then now I'm going to go ahead and graph everything I have. So I have a vertical asymptote when x is -1. So at -1, I'm going to do a dotted line. And then I have a slant asymptote here. So for my slant asymptote, I have my y-intercept is -1. So I'm going to go to -1, put an open dot. So I'm doing an asymptote. And then my slope is 2. So my slope is 2, so that means I'm going to go rise over run. So I'm going to go up 2 over 1. Right? So my y-intercept is -1 with a slope of 2, so up 2 over 1. And then I'm going to do a dotted line connecting. And then that, so a slant asymptote is just your diagonal, right? Your diagonal asymptote. Okay. And so what I know is that when I have a vertical asymptote, so this is my vertical asymptote, I have a branch on the left of it and the branch on the right. So I need to have 2 graphs, one on either side of the vertical asymptote. So I have an x-intercept at 0 and -1/2. So kind of smushed in there, so that's really tight. So I have both of these x-intercepts have a multiplicity of 1, right? So if I look at the original, there's just powers of 1. So that means they're pass-throughs, right? So when I go to connect these, I'm going to go through both of those dots, right? Because if this was a squared, I would bounce. So we're pulling in our chapter 3. So when I go to connect these, I'm going to connect like with a little U shape here. And they're going to pass through, so they're going to go through. So, but I have to be aware of my asymptotes because they act as guiding values or guiding lines. So when I go to connect, it's gonna, the vertical asymptote is gonna guide me towards it and run parallel and not cross. Okay, so that's kind of hard to see there, but so towards it and not cross. And so this asymptote is gonna act like a guideline as well. So I need to go towards it, right? So I need to go towards it and run parallel and not cross. So it's kind of smushed in there, but it's kind of that U shape, right? Where it kind of fans out to like follow this diagonal. Okay. So then once I get that, I need to graph the other side. So this is my right branch I just graphed because it's on the right side of the vertical asymptote. Now I need to graph my left branch. So in order to graph the left branch, I have no information right now, right? I don't have any ordered pairs, no points plotted. I have to create those myself. So I'm just going to do a t-table, and I'm going to do it just down here. And I'm just going to pick any number to the left over here, so to the left of -1. So I'm going to choose -2 and -3. So just to get a couple of dots to kind of guide me on the graph. So I'm going to replace x with -2, so I'm looking up here. And then 2 times -2 is -4. And then -2 plus 1. And then just do that arithmetic. So that will give me -3 times -2 is +6 over -2 plus -1 is -1. So that gives me -6. So then I go to -2, -6. Oops, one more, so right there. So I went -2, -6, and then I'm going to get one more point. So I'm going to replace x with negative 3. So same equation, but replace x with negative 3. So 2 times negative 3 plus 1, and then negative 3 plus 1. So that would be negative 5 times negative 3 is positive 15, and then over negative 2. And so I would just divide that. So 2 goes into 15 7 times with 1 left over, so 7.5. So negative 3 and negative 7, so somewhere around there. So graph paper would probably be better, but close enough. Okay, so now I have to kind of do the same thing, right? I have to like use those 2 dots and then the asymptotes as guidelines. So I know that if I were to connect these 2 dots and I have these 2 asymptotes, so this graph right here has to go like down and towards that asymptote. So I'm going to just kind of make it look like it's bending towards it. And then this one can either go up or it can go down, right? I know it's not going to go up because it doesn't have an x-intercept to come through, right? I already used my x-intercepts. There's not another one up here to use. So that means it has to turn and go down. So it needs to turn and go down and run parallel to that vertical asymptote. And so something like that, okay? And there is 22. Okay, and then let's do one more here. Okay. So this is question 32 on the homework. So question number 32. So the first thing I always want to do when I get a problem is I always want to try to factor and reduce, right? We always want to try to factor and reduce. So x minus 3 doesn't factor. And then for factors of 8, I could use 1 and 8 or 2 and 4. And I know that I want to get a group of 6, so I would want to use 2 and 4. And then either both positive or both negative, and they're both going to be positive because I have a positive on the 6. So 2 and 4. So nothing cancels. So this is what I have for my equation. So I'm going to have a vertical asymptote, and I always look at the denominators for my vertical asymptotes. So I look down here, so that would be one at negative 2 and negative 4. So negative 2 and negative 4. And then I can either have a ha or I can have a saw, right? So I can either have a horizontal or a slant. I can't have both, so one or the other. And I know I have a slant if the numerator has a higher power. So here, the numerator has smaller power, right? So it is not going to have a slant. So that means it's going to have a horizontal, right? So the numerator has to have a higher power to have a slant asymptote. So that means if it's a horizontal, then this one's done different, right? I have to find the limit to infinity. So this is on the previous lesson, right? When we did the limits to infinity. So anytime you do a horizontal asymptote, you always have to take that limit to infinity. So when I look here, this is bottom heavy, right? So there's an x squared here. So I'm going to take a look at that x squared. And then there's not an x squared on the top, but I can always add in a 0 x squared. And I'm just going to add it to the end because I'm kind of crowded. So normally I'd put it up front here. So I can always add a 0 x squared because that doesn't change anything. And that's just to get the degrees to be equal. So there's a 1 in front of here. So then when I take that limit to infinity, it would just be 0 divided by 1, which is just 0. So then I have a horizontal asymptote, so this is equal to 0, at y equals 0, right? Because the limit is always at a y value. So limit is always a y value. Okay, so I have a horizontal asymptote at y equals 0 because 0 divided by 1 is 0. So then I want to find my x-intercepts and my y-intercepts. so for my x-intercepts, I always look at the numerator, right? So x-intercepts, we always look at the numerator, because in order for a fraction to be 0, the top has to be 0. So then my x-intercepts, I'm looking up here, would be x is equal to 3. So then there's my x-intercept. And then for my y-intercept, I just replace all of the x's with 0. So I'm going to take that equation and replace every x with 0. And so what does that give me? So that would be negative 3 over 2 times 4 is 8. So negative 3/8. Okay, so now we have enough to graph, so I'm going to get a graph paper. Okay, so now we're just going to graph everything we have. So we have a vertical asymptote at -2 and -4. So I'm going to go to where x is -2. And then also where x is -4. And then I have a horizontal asymptote at y equals 0, so y equals 0. And then I have an x-intercept at 3. And then a y-intercept at -3/8. Okay, so I'm going to have 3 branches. So how do I know I have 3 branches to graph? So I have 2 vertical asymptotes. So I have to have a branch to the right of it, in between them, and to the left of it. So to the right of it, I have these 2 right here, right? So I have these 2 graphs right here. So I know that this is a pass-through x-intercept, so the graph has to go through it, right? Because there's no multiplicity of 2 up here, right? It's just a normal. If this was a 2, then it would bounce, right? So this is just a normal pass-through x-intercept. So that means it's got to go up, right? So it's got to cut through the x-intercept. But when it cuts through it, it also has to go out towards infinity. So then that means that it's got to go up and then come back down and then run parallel. And we don't know where that point is. We're just kind of randomly putting that somewhere. But I know it's got to go up through, right? And then come back down and run parallel. And then now headed to the left, it's got to run, right? Run towards this asymptote and not cross it. So that means it's got to turn, right? And then it's going to go downwards. Okay? So it's going to go run it towards it and then downwards. Now, how do I know it goes down and not up? So I know it can't go up because there's not another x-intercept for it to come through, right? So the only x-intercept we have is right here. So it can't turn and go upwards because there's no dot here to go through. So it has to go downwards, okay? So then now for the rest of these, I don't have enough information, so I'm just going to randomly find values. So I'm going to do 1, 2, 3. So I'm going to plug in or substitute in -3, -4, and maybe oops, wait. How about 5 and 6? I jumped over one of my values. So -3, so -4 is the vertical asymptote, -5 and -6. So then I'm just going to find, like, when x is -3, -5, and then -6. I'm just going to, substitute those values in and get those points. So I'm just looking at my original equation, but I'm going to write it down here so it's in the screen. So I'm just going to replace x with -3, and I'm going to do a little bit of this math in my head here. So I'm going to do -3 minus 3, and then -3 plus 2, and then negative 3 plus 4. So that would give me negative 6 divided by negative 1, which is positive 6. So I'm going to plot that ordered pair. And then substitute in negative 5, so negative 5 minus 3. And then negative 5 plus 2. And negative 5 plus 4. So that would be negative 8 over positive 3. So that is, what is that? 3 goes into 8 twice with 2 left over, so like 2 2/3. And then I'm going to substitute in negative 6. So negative 6 minus 3 is negative 9. And then negative 6 plus 2. And negative 6 plus 4. So that would be negative 9 over 8, or negative 1 1/8. So then now once you get those values, just plot your points. So negative 5 and negative 2 2/3. So somewhere around here. And then negative 6 and negative 1 1/8. So somewhere right there. Okay. All right, so I have these 2 dots here, so that gives me a pretty good indication of what the graph is going to do. So I know that I'm going to connect here, and then I'm going to go towards the asymptote, and I can't turn up because there's not an x-intercept right here. So I'm going to turn downwards and run parallel. And then again, I don't have another x-intercept, so it's just going to go up towards the asymptote and run parallel. Okay, so now I have this 1 dot right here, right? So can this graph go downwards? And it can't, right? So this graph can never come down because there's no x-intercept here, right? Because the only one I graphed was this one right here. So because I have no x-intercepts, but I have to go towards the asymptotes, I can't go downwards at all, right? So there's no way for me to draw down because I can't cross the x-axis because there's no dots to pass through. So that means it's just going to go up, right, on both sides, kind of like a parabola shape. So we're going to go up towards the asymptotes and then not cross. And so it gives you kind of that parabola shape is all that we get there. Okay, and then that's it.